Okay, so remember from the Pythagorean theorem lesson is that the side that is always across the 90-degree angle is your hypotenuse, right? So the hypotenuse of this triangle is side C. Now we are going to focus on how the other two sides relate to angle A. So what I'm going to do now is we are going to focus on angle A. And there are two other sides when you talk about a right triangle in reference to one angle. So if you look at this angle, angle A, the side that's across from it is called the opposite side. And the side next to it is called the adjacent side.
Is this Sohcahtoa?
Yes. Okay. So this is Sohcahtoa. So side A is opposite. Angle A, and side B is adjacent. Angle A. Okay. So once again, let's look at the triangle on the right. It's actually the same triangle. The hypotenuse is still going to be side C. However, if we're going to focus on angle B here, right? This time, going across from it, this is our opposite, and this is our adjacent. Okay? So side A is now adjacent angle B, where side B is opposite. So one big thing that not really confuses students is that depending on which angle you are looking at, the opposite and the adjacent will change, right? The hypotenuse is always going to stay the same. But if we're looking at it here, angle A, this is opposite, this is adjacent. But now if we look at angle B here, side B becomes opposite and now side A is adjacent. So it actually does matter which angle you're referencing here. Okay? And it's always easy. The one opposite is the one across from it. Simple. So you have 3 trig ratios here. 3 trig ratios are some of the most important ratios you'll see in math. If you, depending on what happens with this coronavirus, if there is an SAT that you're going to take in the fall, you need to know these trig ratios. Okay? So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. Okay. Now there are a couple, I'm going to leave it on here for a while. Couple of things, they are called sine, cosine, and tangent. But when we abbreviate them, we do not write sine, cosine, and tangent. We use a 3-letter abbreviation for each of them. So you can see here, even though it says S-I-N, we don't pronounce it sin. It's sine. This is cosine, the C-O-S, and tan is tangent. Okay, sine, cosine, tangent. This symbol next to it is the Greek symbol theta. That is theta as in what I'm typing out in the chat. Theta. It's just what we use to mean angle in trigonometry. Okay, so sine of a mystery angle is always going to be the opposite over the hypotenuse. Cosine is adjacent over the hypotenuse, and tangent's opposite over adjacent. Now there is this one mnemonic that we all kind of know, and that is your Sohcahtoa. This is the big thing to remember all of these trig ratios, right? And those of you have not seen this before, you could see how this translate here. So S, C, and T stand for sine, cosine, and tangent. And so now look at the two letters that come after the S. O and H mean opposite over hypotenuse. Opposite over hypotenuse. Cosine has an A and H after, so that means it's adjacent over hypotenuse. And then tangent has the O and the A, so that means if I look at the angle, it's the side opposite over the side adjacent. And these are just fractions. They're ratios. They're nothing more than that, right? Yeah, so this is super important that you know. It's the simplified version to remember what I wrote out there. Okay. So let's just do a little practice with this. I have a triangle here. So let's remember Sohcahtoa. And so now the first question asks for sine of A. So whenever you do any of these trig questions, always identify your hypotenuse first. The hypotenuse is C because it's across the 90-degree angle, right? So now let's do the first row. We're going to focus on side A. Angle A, sorry. So if this is my hypotenuse, remember the one across from it is always the opposite, and the one next to it is the adjacent. So if I want to find sine of A right here, sine of A is opposite over hypotenuse, O over H, right? Opposite over hypotenuse, that's sine. So if I look at A, the opposite is side A, and the hypotenuse is side C. Okay. Now let's look at cosine. Cosine A is adjacent over hypotenuse, right? So if I look at angle A, the adjacent is B, and the hypotenuse is C, right? Because cosine is A over H, right? And then tangent is my last one. That's O over A, OA, right? TOA. So it's opposite over adjacent. That's A over B.
Mister,
Yeah.
why in the first one does it say A over C plus A over H?
No, there's no plus. That's this. Hold on. Okay. This is this problem. This is this problem. And this is this problem.
Oh, okay.
Okay. So now let's go ahead and look at the bottom. So this is what I was talking about before. This time, we're not focused on angle A anymore, right? Now we are focused on angle B. So now we're focused on angle B here. So if I focus on angle B, this now becomes my opposite, and this becomes my adjacent. You see how the hypotenuse never changes, right? So once again here, sine of B. If I'm using my Sohcahtoa, sine is opposite over hypotenuse. So this time my opposite is B, and my hypotenuse is C. Okay. Cosine is adjacent over hypotenuse, right? And so if I'm looking at angle B, my adjacent is A, and my hypotenuse is C. And then now tangent of B, okay? Tangent of B, once again, is opposite over adjacent. So if I look at B, my opposite is B, and my adjacent is A. Okay, before we move on, is everyone okay with this? Tony, like I know you came from a different school, so I don't know if you've learned this yet. Emily, and I know Emily Rosales, I know that you haven't taken the second semester of geometry. So is everyone okay where we got these ratios from?
Yeah.
Okay, cool. Okay, so now let's just do a little more practice with this. So now we have triangles, and now instead of saying A, B, C, we actually have numbers here. So once again, we will not forget that we have to remember Sohcahtoa. So I'm going to always write it when we're doing problems here. Okay, so let's do the left column first. We're going to focus on angle A. Remember, whenever you do these problems, first thing, always identify your hypotenuse. And then now if I focus on angle A, this is my opposite. This is my adjacent, right? Because the one across from it's always the opposite. The one next to it's always the adjacent. So sine A, once again up here, sine is opposite over hypotenuse, right? We're using the Sohcahtoa. So opposite is 16, hypotenuse is 20. However, you should always reduce it. I could divide by 4, so this is 4/5. Cosine A, so now we're going to go back to the Sohcahtoa. Cosine is adjacent over hypotenuse. My adjacent is 12. My hypotenuse is 20. I divide by 4, and I get 3/5. Okay. Tangent of A, that is, once again, go back to the Sohcahtoa. Tangent is opposite over adjacent. And so this is 16 over 12. I divide both by 4, and that's 4 over 3. And now if I do the second column, you see how we change our angle of focus now, right? We're not focused on angle A anymore. Now we're focused on angle C. So if I focus on angle C this time, you see how this becomes my opposite now. This becomes my adjacent. One of the things that I see a lot of students get confused on is if they have to find the sine of two different angles, once they label it opposite adjacent from the first angle, they don't change it when you change angles. When you change the angle you are focusing on, the opposite and the adjacent will switch. Okay? So the sine of C is opposite over hypotenuse, right? So this is going to be 12 over 20. I divide by 4. That's 3/5. Cosine of C is 16 over 20. Divide by 4. That's 4/5. Tangent of C is opposite over adjacent. That's 12 over 16. Divide by 4. That's 3/4. Okay. Okay, one more time so you guys can be super familiar with this, because this is really important, like I said, especially those of you that are moving into trig next year, right? Really important that you know this. So here, for this question, across the 90 degrees, this is your hypotenuse. Now, if we're just focusing on x, that's my opposite. Okay. And the one next to it is my adjacent.
Mister, do we have to take trig next year?
No.
All right.
Okay. So in this question, sine of x is going to be opposite over hypotenuse. So this is going to just be 20 over 29. You can't reduce that, right? Nothing really goes into 29. Cosine of x is, once again, adjacent over hypotenuse. That's 21 over 29. And then tangent of x is opposite over adjacent. And that's 20 over 21. Okay. So the right column, this time we are changing our angle of focus. So never keep the opposite and the adjacent the same, right? That's what you had a question. No. So this time, if I focus on angle Z, this becomes my opposite. This becomes my adjacent. So the sine of Z is opposite over hypotenuse. That's 21 over 29. Cosine of Z, once again, the adjacent over hypotenuse in the Sohcahtoa, that is 20 over 29. And then tangent of Z is opposite over adjacent. This is 21 over 20. Okay. Before you move on to the you try, I want you to notice some things here. Look, the sine of one angle is actually the cosine of the other angle. Same thing happens here. Look, the sine of one angle is the same as the cosine of the other. Because remember, all that happens when I change my angle of focus is my opposite and my adjacent just switch, right? And so that's why you see this happening here. And look what happens between the two tangents, right? They just get flipped. The tangent of one angle is reciprocal of the tangent of the other. So I want you to kind of very quickly do these next ones on your own. Please try them. I don't want you to just sit there and wait for me to go over them. Try them to make sure you understand what is going on here, and so we can correct any mistakes before you start doing your assignment. So please do these right now. And then I'll give you a couple minutes and we'll go over them. Remember, the first step is to always label the hypotenuse. The hypotenuse is the first one you should always label. Anyone have any questions though? Okay, let's look at the first triangle. So remember, always label your hypotenuse first. This is your hypotenuse, right? So if I focus on angle X, the one across from it is the opposite. This one's my adjacent. So sine of X should be 12 over 37. Cosine of X should be 35 over 37. And then tangent of X is opposite over adjacent. That's just 12 over 35. Any questions with that one? Okay. Now, if we focus on angle Z, this is my opposite. This is my adjacent. So the sine of Z is 35 over 37. The cosine is 12 over 37. And then the tangent is opposite over adjacent, 35 over 12. Anyone have a question on that one? So this one's my hypotenuse. If I look at angle A, that's my opposite. This is my adjacent. So sine A is going to be 28 over 35. However, I could simplify this by dividing by 7. This should be 4/5. Always try to simplify. Cosine of A is adjacent over hypotenuse. That's 21 over 35. I divide by 7. That's 3/5. Tangent of A is 28 over 21. Divide by 7, and that's 4 over 3. Okay. Now, if I change my angle of focus, the sine of C, so this time this one's my opposite, this is my adjacent, right? So your opposite and adjacent will change depending on which angle you're looking at. So this time this is 21 over 35. Divide by 7, that's 3/5. Cosine of C is 28 over 35. Divide by 7, that's 4 over 5. And then tangent of C is opposite over adjacent, 21 over 28. Divide by 7, and I get 3 over 4. Okay, cool. Anyone have any questions on that? Okay, so let's move on then. For some reason, this guy kind of got cut off, but remember that you could use Pythagorean theorem to find the missing side of a right triangle if you know 2 of the other sides. So in last class, you did something like this, right? Where you just did, you did a squared plus b squared equals c squared, right? Now, you do Pythagorean theorem when you have 2 of the sides and you're looking for a third side. You should automatically do a Pythagorean theorem when you have that. Now, however, you're going to use trig ratios when you know one angle and one side. If you know one angle and one side and you know it's a right triangle, then you know here you're going to use Sohcahtoa. Remember, when do you use Sohcahtoa? When you know one angle and you know one side. If you know 2 sides, you're going to use Pythagorean theorem.
Is this just the basics of Sohcahtoa? Is this just the basics of Sohcahtoa?
Yeah, basically.
I'm sorry?
So let's review how to use Sohcahtoa to find missing sides. Whoops. So there are 4 steps here. Identify the angle given, identify the given side and unknown side, identify which trig ratio to use, and we're going to set up an equation and solve it. So a couple of things here. I'm going to need you to take out a calculator or a phone calculator. Okay. And I'm going to show you, make sure we all are on the same page when we do these problems. So here's how to do these Sohcahtoa problems to find a missing side. So first step is to identify the angle that is given to you, which is the 18. Okay. From this 18, you are going to label your triangle. So the hypotenuse is always across the 90-degree angle. Whatever is across the 18 is the opposite. Whatever is next to the 18 is the adjacent. Okay. Now, next step is to identify the given and what you're looking for. So the given is the 17. That's your adjacent. What you're looking for is the x. That's your opposite. So once you identify the thing you're looking for and the thing you're given, you're going to go back to Sohcahtoa. And so now here you see that I'm looking for my opposite and I'm given my adjacent. So you're going to think to yourself, which ratio, sine, cosine, or tangent, uses opposite and adjacent? Well, that's really simple to figure out because you're just looking for O and A. O and A here is tangent. So this problem, you are going to use tangent. If you use sine and cosine in this problem, it is going to be wrong. Does everyone see how we were able to identify we are going to be using tangent in this problem? Right? I'm given the adjacent, I need the opposite. So I'm going to write an equation using tangent. So the equation is going to look like this. Tangent of the angle, which is 18. Okay, so now in the past, in this lesson, you saw sine x, cosine x, tan x. Now we actually have what that angle is. So I'm going to write tan 18. And remember, tangent is opposite over adjacent. So we're going to write an equation. Opposite is x. Adjacent is 17. Okay. So tan 18 is equal to x over 17. And then from here, all I'm going to do is I'm going to multiply both sides by 17. Oh yeah, so I'm still solving for x, right? So how do I get rid of that 17? If I'm dividing by 17, I'm going to multiply both sides by 17. This cancels, and so now x is equal to 17 tan 18. Okay, so get out your calculators. If you have a regular calculator or you have an Android, this is how you're going to type it in to your calculator. You're going to type 17 times tan 18, and you're going to get an answer there. Okay? If you have an iPhone, this is what you're going to do. You're going to type 17 times 18 tan, and then press equals. Okay, so you have to plug in that tan 18 in reverse. So once again, regular calculators and Androids, go ahead and just do 17 times tan 18, press equals. If you have an iPhone, you're going to press 17 times 18 tan equals. And then you should get an answer. And it says round to the nearest 10th. So you should get an answer like 5.523634 or something like that. So if I just round it, I get 5 points.
Mister, can you repeat how to do it for our iPhone again?
Yes. 17 times 18 10. And then press equals. Okay. Anyone else? Everyone was able to get the 5.5? Okay. Since no one said no, I assume everyone was able to do it. Let's move on to the next problem. So once again, let's identify the steps we are doing here. First thing, identify the angle here. Then we are going to label the triangle based on the information. Remember, whatever's across from the 90-degree angle, that's your hypotenuse. Whatever is across from the angle is your opposite. And whatever is next to the angle is your adjacent. Okay. So next thing, what's my given? It's the 14. That's my hypotenuse. And what am I looking for? That's the x. That is my opposite. So I go back to the Sohcahtoa and I see which one has opposite and hypotenuse. What has the O and what has the H? So this time it's sine, right? Sine has the opposite and the hypotenuse. So if I'm going to write an equation here, I'm going to use sine. So I'm going to write sine 69 is equal to the opposite, which is x, over the hypotenuse, which is 14. And then so now I just solve this like a regular equation. I'm going to multiply both sides by 14. And so x is equal to 14 sine 69. And so once again, please use your calculators and make sure you get the correct answer. Same thing again, calculators and Androids, 14 times sine 69 equals. iPhones, 14 times 69 sine equals. And you should get an answer of about 13.1 if you round it, I think. Yeah. Okay. Okay, so one more with you. Once again, first step, identify the angle. And then now just label the triangle based on that angle. This is your hypotenuse. The one across from it is your opposite. And the one next to it is your adjacent. Okay, so once again, identify what's given. That's the 12, that's your hypotenuse. And what are you looking for? The x, which is the adjacent. So adjacent and hypotenuse. This time, I look for the a and the h in the Sohcahtoa. That's cosine. So this problem, I'm going to do cosine of 36. Oops. The adjacent is x. The hypotenuse is 12. I multiply both sides by 12 to get rid of that 12 on the bottom. And so x is equal to 12 cosine 36. And you should get 9.7. Okay. So I want you to at least try the next one by itself. And if you're done with that, try the next 2 or 3, depends on how much. But I'll give you maybe a minute or 2 or 3. But I really want you to try these on your, try at least one on your own to make sure you're getting it correct and identifying which trig ratio to use. Okay. So once again, this is your angle of focus. This is your hypotenuse. That's your opposite. This is your adjacent. So this time they give us the 10, that's your hypotenuse. They give it, and we're looking for x, that's the adjacent. So I know this is a cosine. So hopefully you guys saw that this was cosine. Cosine 35 is equal to x over 10. Multiply both sides by 10. So now x is equal to 10 cosine 35. And so this should be 8.2. Okay. And I'll do this other one just in case you were able to get to this one. Once again, angle of focus is 49. So across the 90-degree angle, that's your hypotenuse. Across from the angle is your opposite. This is the adjacent. So this time they give me the hypotenuse. I'm looking for the opposite. So opposite and hypotenuse, that's sine. So I'm going to do sine of 49 is equal to x over 15. Multiply both sides by 15. So x is equal to 15 sine 49. So this is 11.3. Okay. If you did do the last one, you'll realize that it's tangent. Okay. Tan of 38 is equal to x over 19. And then you just multiply both sides by 19. Okay. Now, if you look here, I'm going to show you the last couple of problems. And the only thing that's different about the last couple of problems is you see whenever we did these questions, the x always appeared on the top. On the bottom, the x will appear on the bottom. And let's see what happens when that happens. So, last couple of problems here. However, the way you do these is the same thing. Always start with identifying the angle, right? The one across the 90 is always your hypotenuse. The one always across the angle is your opposite. The one next to the angle is the adjacent. So this time, once again, let's identify. Hold on, let me write this here. So once again, let's identify what's given to us. We're given the 13, that's our given, that's the opposite. we're looking for the x, that's our hypotenuse. So which one is op O and H? That's sine. Okay. So I'm going to write a sine equation now, and I'm going to do sine of 38 is equal to. However, look, the opposite this time is 13. The hypotenuse is x. So the x is on the bottom now. And remember, we never want x on the bottom. So we're just going to move it to the top by doing the opposite. So here's how we solve it when x is on the bottom. I'm going to multiply both sides by x. So what happens is the x's cancel on the right side. And so now x is on the top, which is what I want. X sine 38 is equal to 13. Okay, the x is still not by itself though. It's being multiplied by sine of 38. So to get x by itself now, I'm just going to divide both sides by sine of 38. So it's very similar to the problem that we had before, except it's division at the end and not multiplication. So what happens on the left is this cancels. And so now x is equal to 13 over sine 38. And then so, once again, try this on your calculators. Do 13 divided by sine 38. However, if you do have an iPhone, you do have to do 13 divided by, press 38 first, and then press sine, and then press equals. The rest of you just type it in as you see it. 13 divided by sine 38, and then press equals. And so x should be approximately 21.1. Okay. So let's see that process one more time. Remember, first step is to always identify the angle. And then now let's just label the triangle based on what we know. Across the 90-degree angle is your hypotenuse. Across the 47 degrees is your opposite. Next to the 47 is your adjacent. And so remember, next step is to identify your given. That's the 11. And you are looking for the hypotenuse. That is x. So once again, I see that I circled adjacent and I circled hypotenuse. Which one of these is the one? It's cosine, A and H, right? So I'm going to use the cosine equation. So cosine 47. The adjacent is 11. And the hypotenuse is x, right? Adjacent over hypotenuse. So now I'm just going to multiply both sides by x. Make that a nicer 11. Oops. So it was 11 over x, and I multiplied both sides by x, so these x's cancel. And then so x cosine 47 is equal to 11. And then now I just divide both sides by cosine 47. Okay. And then so 11 divided by cosine 47 is 16.1. Okay. Does anyone have any questions The last one, I mean, I'm just going to go over it very quickly, just because, you know, it's the same thing over and over. 47, this is my hypotenuse. Across the 47, that is my opposite. And this is my adjacent. So once again, what's given to me here is the opposite. What I'm looking for is adjacent. So opposite and adjacent, that's tangent. So this is going to be tan 47 is equal to opposite, which is 14, adjacent, which is x, and then now I just multiplied both sides by x. Whoops. And then so I get x tan 47 is equal to 14. Divide both sides by tan 47. And then so x is equal to 14 over tan 47. When you do the work, you don't have to write this step here. You could just divide 14 and tan 47 and just give me the answer. So 14 divided by tan 47, that should give you around 13.1. Okay. So that's it.